In this video I'm going to show you my process for using Siril. It's probably not the best way of processing images, it's just the way that I do it, and I've based this on watching a large number of videos on YouTube. Now I'll do all of the processing inside Siril now. In order to do that I do have some scripts installed. So I have the Seestar pre-processing because these images are coming from my Seestar S50. You can find the scripts over here on the scripts tab, and if you scroll down you can see the ones that I've selected. I've got Graxpert AI. You'll need to install Graxpert, it's free. And then I've got Cosmic Clarity scripts. You'll need to install the SETI Astro software for Cosmic Clarity, or go and find Cosmic Clarity. You can download that and then these will become available. And then we've got the Seestar pre-processing. This will allow me to set up my images like I have over here. I'm going to be using subs from M8, the images from M8. I've put a directory inside this folder called Lights, and inside Lights are all my FIT files, and I've got 91 FIT files in there. Once I've done that, I am ready. I need to come into Siril and set the home directory. The home directory is where my Lights folder is, not the Lights folder itself, but the folder where the lights are. I've got all mine organized over here. That's the folder, so that's the working directory set. I can now come up to scripts, go down to Siril scripts, Seestar pre-processing, and over on the right you'll see that it's now going through all of the files, all those FIT files inside that lights folder. It's now completed, it's rejected some, it's then stacked the rest to produce a file, which if I click on open, it will open in my working directory. That is the file I want, the FIT file. If you don't see it immediately, you can just click on type and you should then be able to find it. It's the only FIT file in that working folder. That is the lights folder where all my images from the Seestar are. This is the file that was produced by the Siril stacking. Now you don't see anything at the moment because all of the data in that image is all pushed over to one side, so we need to stretch it. We can have a look what it would look like with an auto stretch. So that is roughly what this is going to look like. And the first thing that I'll do is come up to image processing, remove green noise and apply. The next thing is to remove any background that is not wanted. You can do background extraction there, but because I've got Graxpert installed, I'm going to come across to my Python scripts, come down to Graxpert AI, and I'm going to leave this all as it is. You can do background extraction and you can do denoising. I'm going to click on apply to remove the background, processing complete. We can also do a denoise at this stage if you want to. And this is processing. Okay, that's now completed. We can close that. Now we need to color calibrate the image, but the software Siril needs to know what this is, so we need to come up to Tools, Astrometry, Image Plate Solver, and it should have all the data up here. If not, you can type in the target, in this case M8, and it's found it. Click on OK, and then that's Plate Solver. Siril knows where this is, and it's going to know how to calibrate the color. So I'm going to color calibration, spectrophotometric color calibration. For my Seestar S50, it's one-shot color. And then just choose the Seestar S50 sensor. There's no filter on this. I'm going to click on OK. We'll get a graph or two showing white balance, and then I can close that down. And we're now ready to remove the stars. So I'm going to come up to image processing, down to star processing, star removal. Now this does need Starnet installed, so have a look on YouTube for a tutorial on that. Once you've installed Starnet, you need to tell Siril where Starnet is. Again, there's a video on YouTube that'll tell you how to install it and tell Siril. Let's execute, and this will now go through and look for all the stars in the image, and when it finishes the run, the stars will be removed and all we'll be left with is the nebula. And there we go. There is a fair bit of noise in there, so let's just firstly start by saving, and then I'm going to come up to my Python scripts again, come down to Cosmic Clarity, and we'll denoise. I'm going to do a full denoise, and you'll hopefully see when it's done that the noise is reduced. Okay, that has now reduced it. There's still some noise, but it's a lot better. Now this auto stretch is not how the image actually looks. If I opened this image in an image editor, it would actually look more like this, because that is what it currently looks like. We need to actually stretch it. This is just a visual tool to show you what it could look like, but this is what it actually looks like. For stretching, we come up to image processing, and there's a couple of options here. You could try the histogram transformation, and then there's a button here that will auto stretch. Quite often when you auto stretch, you'll find that the clipping here goes above 0, and that's not something that you want. I'm not going to do it this way. I'm going to do it a different way. I'm going to come up to the generalized hyperbolic stretch, and for the first stretch I normally raise this to about 7. Not too sure why, but then we can bring this one up and you'll see that the nebula starts appearing in there. Click on apply and then just keep on stretching it to bring out the nebula. The background is also getting lighter, so I'm going to change this over here to the linear stretch and change the black point. And as I move the slider to the right, you'll see the histogram goes across to the left, and that's what we want. We want it right across to the left without actually losing anything. And you can see down here now it's clipping. So I'm going to use the fine tuning to remove the clipping, get that down to 0, and click on apply. And then I can switch back to the generalized hyperbolic and bring out a bit more detail in the nebula. You can keep doing that until you're happy with it. There are other sliders down here, but I'm not going to go into what they do. If we zoom in a little bit now, you can see that is our starless image. After we've done the hyperbolic stretch, we can go in and do color saturation. We can try and play around with the colors a little bit if we want to change the color, and you can do it by different channels up there as well. I'm going to just leave it at that, click on apply, and I'm now ready, I think, to recombine with my stars. So I'm going to click save, make sure the image is saved, and then come to star processing, star recomposition. And there's two sides here. The left side is where we put in the starless image we've just been working on. The right side is where we put in the stars. So I'm going to open up my working directory. There's one called starless, one called star mask. This one up here, this fit, that is the one that was created from the stacking, so you can always go back and start again if you decide you have made a mess of it. So I'm going to put starless over on the left. You can see that the nebula is there. I'm going to come across to this one and put the star mask. And you can continue stretching if you want to, so we could stretch this a little bit more and then just apply when you are happy with what you've done. And on the right hand side we can bring the stars in by pulling this stretch factor over on the right hand side. Now you don't want to overdo the stars, that might look a little bit overdone. You want the nebula to be the main thing, but in the final step of the process I'm going to do a sharpen, and when I sharpen it all of the stars are going to get a little bit smaller, so I like to go a little bit over the top at this stage. Let's click apply for both of those and close, and I'm going to come up now and do my final couple of runs. I'm going to do a denoise, and we'll do a full denoise. So that is completed. And the other thing I want to do is sharpen. So back to Cosmic Clarity, sharpen. And incidentally, first time you use these, you'll have to tell Siril where these scripts are on your hard drive. That's why you installed this earlier. You'll just have to go into that folder and find the relevant tools. I want to do both. Click on apply. And as this completes, you'll see the stars all get a little bit smaller. And that has now completed. I can come and save it, come up to supported image files. I want to save it into my final images. This one is M8, so I can come up, give it a name, M8. There is already one called that, so let's just click on replace, and then I'll save it also as a JPEG and as a TIFF, just so I have more options for working with these. Come back to my final images folder, save, replace, save. If I now go in and have a look at my final images folder, I can see that I've got my M8 TIFF, my M8 JPEG, and I also have an M8 FIT file which GIMP can open if you wanted to do further processing in GIMP. If I open up my JPEG, that then is my final image for M8, the Lagoon Nebula. Now obviously I'm no expert at using Siril, this is just the way that I do it. If you have a better method, or if you see something that I'm doing wrong that could do better, then please let me know in the comments.